Hey everyone, it's Emily with Spiceworks. Thanks for tuning in today and joining us on another Spiceworks Partner webinar. Hyperconvergence, what is it and how do we get here? Brought to you by Scale Computing. Before we get started, I want to remind everyone that the webinar will be recorded, so if you have to step away for any reason, you will get an email with a link to the video in about a week. Also, there's a Q&A box on your screen to the left. We encourage you to submit your questions at any time during the presentations. We will get to those questions at the end of the webinar via a verbal Q&A. So if your question isn't addressed live, Scale Computing will be able to follow up with you. Now that all the housekeeping is done, I'd like to introduce our presenters. David Davis, vExpert, VCP, CCIE, and video training author, and Craig Thirak, Director of Product Management with Scale Computing. So David, whenever you're ready, take it away.
Thanks very much. I really appreciate that introduction. It's an honor to be speaking today and presenting with Craig, who I've been presenting with now for a while around hyperconvergence specifically. So we've got a lot to talk about here. Let's go ahead and get started. First, just a little bit more about us, our background, because I think you'll see it pop up here and there throughout the webinar. I've been in the IT industry now for over 20 years. I started off as a server admin. I worked as a network admin, later as an IT manager for a medium-sized organization. We had about 80 remote sites and about 100 servers in our data center. And it was there that I really gained my passion for virtualization. And we had a very successful server consolidation. And I started writing and speaking at my local user group about virtualization. So ever since then, I've been creating training and writing and speaking around virtualization. And lately, I've been learning a lot more about hyperconvergence and talking more about the benefits of hyperconvergence. So it's a great topic we've got lined up for us here today. I'm proud to be speaking with Craig. Craig, again, is the Director of Product Management at Scale Computing. And Craig he spends his time with hundreds of small IT organizations, helping them learn about the value of hyperconvergence and virtualization, and helping them solve real-world business problems around disaster recovery, backup, server consolidation, and so forth. He's also got many years of IT experience, and he's got a great presentation lined up for us today as well. So with that, let's go ahead and get started. Our agenda here today is first to talk about the challenge that I know many companies out there are facing in their data center. The sneak peek, the secret, if I let it out of the bag right now, is do more with less. You might have heard that phrase before. From there, we'll talk about the basics of convergence, what convergence is, how it works, how it all fits together. We'll discuss the convergence continuum, basically how convergence has been changing over time. Maybe convergence has been converging a little bit over time. And then Craig has got a great Scale Computing demo for us, which is a very nice hyperconvergent solution. So we can see it in action. We can see what it's like to really administer a hyperconverged infrastructure. So with that, let's go ahead and get started by talking about the challenge that I think most companies out there are facing, and that is, in many cases, just too much complexity. The data center is just filled with server, network, storage. You've got advanced solutions like high availability, disaster recovery, backup, complex applications. And I think most IT people, while we love complex things and solving complex problems, in most cases we just wish each day that things could just be less complex. Why do things always have to be so difficult? Why do the problems always have to be so complex and so time-consuming to solve? We'd much rather be helping out the business to do something where we get visibility and we really help the company, let's say, make more profit instead of solving complex, computing problems. So, the other problem here is the increasing number of demands, versus the decreasing IT budgets that I know so many companies are facing, and I went through that as well. And virtualization was a huge lifesaver for my company personally, where we only had one administrator basically for the 100 Windows servers that were in the data center, And that administrator also had to administer all the associated applications, web servers, Exchange, file, print, specialized applications, and so forth. So we didn't have many resources, and as we increased the number of applications and the number of servers, we couldn't hire more people. We didn't have the budget to hire more people. And then when the economy went down, we were faced with laying off people in many cases, but yet the IT infrastructure, in most cases, it didn't decrease either. So these increased demands at the same time were being pushed with decreased budgets in IT. And we're just expected to do more with less. And a lot of that comes from, I think, the consumer side of electronics, where we get everything on demand. We get Netflix and our iTunes music and movies just with the click of a mouse. And, on our iPhone, we expect everything to just work. Or our Android phone or Windows phone, we just expect it to work and be easy. And then we walk into our office and we expect our computer to work the exact same way and be up 24/7, 365. And that's hard to do, with very few people and on a small budget. So my recommended answer, and I believe the answer that most people would love to see, is simplification, right? How can we simplify the data center that would allow us to do more with less, to meet these technology expectations, like, let's say, high availability that the company and the employees, expect from us? How can we provide for the increased number of, servers and applications that the company needs without adding many more administrators, which they won't let us hire in most cases? And then how can we decrease the stress on admins? I mean, I'm sure there's many admins out there in small shops who would just so much rather spend their day learning about, let's say, the next version of the new operating system or a new application, or enhancing their knowledge so they can help the business instead of solving complex technology problems. So simplification, how can we get to simplification? To me, virtualization is the immediate first go-to solution. If you haven't started virtualizing your servers, it's a great time to start. Virtualization is mature. It can support really every application out there, and it can make you so much more efficient and be able to do amazing things that you never dreamed of before with physical servers. Virtualization, in many cases, though, also has some challenges. You need shared storage to provide high availability with most virtualization platforms, and you still have the complex sort of blame game that can happen. So you might have a virtualization vendor, then you have a server vendor, then you have a guest operating system vendor and the storage vendor. And especially in smaller companies, we don't want to get into all that. We just need something that works, and we need one phone to call, one person to ask for help if we can't figure out the problem. So we don't need that greater complexity in many cases that a virtualization might bring. Virtualization is also causing the rise of what I call the infrastructure engineer. So the infrastructure engineer is just kind of the jack of all trades who's expected to be the linchpin, really, of the data center and knows everything. Knows storage, knows network, knows virtualization, and the compute layer as well. And so that's something we have to try to rise up to meet. But at the same time, if things are more complex, it's difficult to do that, right? Virtualization also brings into the equation the I/O blender effect, which means, before you're with a locally attached disk, your compute and your disk were all on the same I/O path. But with virtualization, when you blend those together, the data gets all mixed up, and it can actually create I/O throughput, inefficiencies and some latency. So that's something we have to take into account, and just the time to deliver new services, to the company, or solve problems. If the company is experiencing downtime, we need to be able to solve those as quickly as possible without, finger pointing and complexity. And I actually wrote a blog post about, becoming an infrastructure engineer before it's too late back in 2011. To get out, if your company's big enough to have the compute server, network and storage silos of administration, we need to get out of that. We need to flatten the IT infrastructure administration, the data center administration, But in most cases, the only way to do that is through simplification. And to me, that's what hyperconvergence can bring us. So now let's talk about hyperconvergence specifically. The characteristics of a hyperconverged platform is greater efficiency, greater optimization, many of the features that virtualization brings, but also because hyperconvergence is the combination of the compute and the storage resources into one, you get a single shared storage resource pool. So if you are used to administering a storage area network and carving up, different ones with different RAID stripes, and then trying to load balance the I/O and the storage capacity between those over time, really all that goes away. All that goes away. The complex connectivity of a storage area network, all that goes away with hyperconvergence. So you get a single point of management, a single point of administration, a single point of visibility. Some of the other hyperconvergence characteristics are a total cost of ownership improvement. So you get a greater return on your investment. So instead of having to purchase dedicated storage and compute, what if you could just purchase one thing that provided all of those services, virtualization, storage, and compute in one? You would get a much better return on the IT infrastructure spending on your budget, and you would get greater simplification, of course. But hyperconvergence goes beyond more than just the combination of servers and storage. And this is where I'd like to start talking about the hyperconvergence continuum. So that's a fancy word that really just means where did we start and how have things changed over time and where are we today? And Craig, feel free to chime in and join me on any part of this here. But first off, when companies moved to virtualization, it was all do it yourself, right? You had a server, you had physical servers, and we would load a hypervisor, VMware, vSphere, or Hyper-V on top of that physical server. And we would basically re-provision physical servers as virtualization hosts. And then very quickly we figured out, hey, we need some centralized storage to store all the virtual machines on so that we can take advantage of high availability and load balancing, let's say, of the compute. And a great place to centralize the storage and to get the most storage functionality was a storage area network or a NAS, a network attached storage device, or VSA. Some people use virtual storage appliances spread across the compute hosts. But as I mentioned before, there's some additional complexity to doing this. Many companies introduced a SAN into the data center when they didn't have one before. It was expensive. It was probably the most expensive piece of infrastructure in the whole data center, and in many cases it was the most complex because it was all new. It had its own separate company, separate vendor supporting it, its own support and maintenance contract, and so on. From there, vendors started offering reference architectures. And a reference architecture is just a fancy way of saying, hey, here's a document that says this is how you put it all together. And if you put it together that way, it should work, and it should support so much load. It should support so many virtual machines. And you would get perhaps these additional benefits. And so companies started offering reference architectures, which is really just going a step further than a hardware support list, like an HCL, a hardware compatibility list, right? Which Windows Hyper-V has and VMware vSphere has as well. So, but the reference architecture takes that a step further, and they say if you use this specific hardware, this specific storage, put it all together, you get this much capacity out of it. And then from there, the next step was converged. And converged is traditional virtualization, but it's all pre-built at the factory, basically. So in the data center, you get delivered, you get the virtualization host, it's already loaded up, and it's ready to go, essentially. After that, there's the VSA, which is where you're virtualizing storage, and we've actually got some great diagrams on this before I ramble on too far about these. Craig,
yeah, I was going to say, David, Yeah, absolutely. I appreciate that kind of overview of the convergence continuum. As you said, it's a big word that basically just means that this has been a long time coming to get us to what hyperconvergence truly is. I'm more of a visual guy, so the charts here and the graphics we have on screen, I think, help me to really kind of digest all this information. If you think about the do-it-yourself virtualization, that first stage of virtualization over the years, what you see on the screen here is really what we saw as that traditional deployment to introduce high availability into the infrastructure. So at the top layer, you've got your virtual machines running on top of, in this case, 3 host servers running either VMware, Hyper-V, Xen, KVM, whatever the case may be, and then using a traditional storage protocol, either iSCSI or NFS. Or some even SMB, connecting down into this shared storage infrastructure, this basically through redundant switches into either a SAN or a NAS. We like to refer to this as our spaghetti slide, and I think it really does a good job of describing what the architecture looks like, but also the complexity that's involved in it. Every layer that you have in this diagram introduces another layer of complexity, both on the initial setup side, but then also the ongoing management. And you kind of mentioned some of the cons around, what we see in terms of the hardware compatibility lists and those types of things. But there are some reasons that you would put this type of complex infrastructure in place. You get all that benefit of virtualization, all the partitioning, isolation, encapsulation, all the hardware independence that you gain out of basically removing the that hardware failure point really in the system. You have the high availability of your VMs, knowing that if for whatever reason a host server fails, the VMs that are running on that host server have access to that shared storage and can start back up on host server 2 or 3 or 4, whatever the case may be. But as we said, there are cons to this. It is complex. A lot of times I have to go out and get training on vSphere, or get training on another hypervisor. You'd have to get training on a SAN or a NAS, maybe networking management as well. In the kind of small to mid-sized company that we target at scale, and what we built our product to solve real problems for, a lot of times these are IT generalists that don't necessarily have the time to specialize in any one of these areas. So this presents a challenge to them to implement, and a lot of time, it could be the reason they never do get around to implementing high availability is because of this complexity. It also could be related to the expense associated with it. As you said, David, the SAN or the NAS a lot of times is the most expensive part of the data center. And if you're really architecting for true high availability, a lot of times you have to put in a second SAN or a second NAS for that failover capability at that storage layer. You'll hear Sam and some of the other guys out in the Spiceworks community call this the pyramid of doom, and that's because it's that 3-2-1 architecture where 3 host servers connected through redundant switching into a single SAN or NAS, and that SAN or NAS can be a single point of failure if it's not architected correctly. So those are the pitfalls of it. But again, there are real reasons people would want to do it. Basically, that was 10-ish plus years ago that this first kind of came on the scene, and since then, I think vendors have slowly reacted to start bringing a more converged look at that whole infrastructure. And that first step, as you mentioned, was just reference architecture. So that the big problem that a lot of small businesses have when they go out to implement a system like this is, what works with what, and who will support that? What happens if something breaks? If for some reason the SAN is having issues connecting into the VM, who do I call? And with these hardware compatibility lists and these reference architectures that encompass them, you at least have a better starting point to say that, yes, these are a known quantity. These should work together. Now, of course, if you go to upgrade any single point in these, you may be breaking some rules around the hardware compatibility list, so that it's still on you as the administrator to stay on top of that. But it is a step in the right direction. It solved real problems for people who just had no idea where to start to even cobble something together around this. And so, here's a document that says exactly what's put together. It's pretty handy. The next thing that we started seeing in the industry was really the first time anybody coined the term convergence around the infrastructure, and it's converged infrastructure. HP had some good products around this. There were entire companies built around this, things like VCE, where, basically where you're taking that same traditional virtualization approach, as you can see in the diagram here, but skewing it up as a single SKU. No longer do you have, to go out there and buy all these individual components. You kind of say, okay, at a rack level or maybe even a half rack level, what do I need to run my infrastructure? Here's the SKU for that, and you put it in place. Now, that definitely helps with the speed to implementing a system like this. It still retains that HCL pre-certified, all the goodness that you had of the reference architecture. But again, you have that time to implement decrease really over the reference architecture and definitely over that traditional do-it-yourself approach. And you also have a perceived kind of one throat to choke. When you go with, say, VCE, you know that your first call is going to be to this company. Now, behind the scenes, because they're dealing with VMware plus, Cisco plus EMC, whatever the case would be, all the different components in there, there may be somebody behind the scenes where they have to offload you to a single company, but it's at least the one throat to choke. Now, under the hood, as you can see from the graphic, you still have the same architecture. You still have to have the expertise at the hypervisor level. You still have to have the expertise at the networking and at the SAN or NAS level. And it's on you to kind of keep that running optimally and grow that as you have to do in any of the previous versions that we looked at, whether it's the do-it-yourself or reference architecture. The next thing that we saw in the industry is this concept of a VSA, where we're abstracting really the hardware piece of the storage layer, very similar to what we did at the host layer. These companies that have come out with virtual storage appliances, VSAs, essentially what they're doing is they're creating a VM that runs on top of the host that is a controller VM, and it basically kind of takes over the functionality that you would see in a controller on a storage array, but does it at the VM level and distributes the storage across all the nodes there. So essentially, you've got that bottom layer there virtualized. You're getting rid of some of the hardware associated with it. You're also you still are gaining that high availability that you're looking for and implementing some form of shared storage environment. But the problem is, it still is complex. In fact, arguably more complex because you're abstracting the kind of the storage layer away from the hardware itself. So it's a little hard to get your head around, at least initially. It still requires NFS or iSCSI. So in all of the models that we've talked about here, essentially what you have to do, and maybe it's best described in this next section here, but essentially what you have to do is make sure that the storage is able to communicate up to the VM itself. And there's a lot of steps that you have to go through to do that. All said, VSAs aren't fundamentally any different or easier to manage than a SAN, but they did, again, because it's another step toward this hyperconverged model, it is removing some of the hardware and some of the failure points associated with that. So that's definitely a benefit of it. Which brings us to hyperconvergence. Some people are calling it hypervisor convergence. There are a number of terms that you're going to see out there. Software-defined storage is kind of blurs the lines between all these as well. But essentially what it is, we're taking that traditional approach where you've got the VMs running on host servers connected down through redundant switching into a SAN or a NAS, and it's collapsing that and taking away a lot of the complexity. So if you think about in this traditional do-it-yourself virtualization that we have on screen here, which as we just showed in the rest of the convergence continuum exists, whether it's in the reference architecture or the converged or the VSA, essentially when you go to create a VM, a lot of times you have to start in the storage layer, create a target, create a LUN, maybe set up chat authentication, multipathing, connect it up through to the hypervisor, log into the hypervisor, go through and create the VM and make sure that it's able to communicate down with the storage. A lot of steps to creating a VM, and again, you're doing all of that for the benefit of high availability. You want to make sure that your VMs are going to remain available for your end users within your company. And so what hyperconvergence does is we've basically removed the complexity of the traditional storage protocols and presented the storage to the VMs as if it's directly attached. And there are a lot of benefits of doing that approach. And actually that's what we've done with our HC3 product at scale. It was one of the first hyperconverged products out there on the market. And I'll show a brief demonstration here in a second, but I did want to tell you a little bit about scale before I go into that. We're based in Indianapolis, Indiana. I'm actually out of our Silicon Valley office. actually this is a little out of date. We actually just announced we're well over 900 clusters out in the field right now, so we're excited about that. Our Net Promoter Score is consistently 75 this last quarter, which was just announced internally here, hit 79. And basically, if you're not familiar with Net Promoter Score, it's a loyalty question that I'm sure you've been asked by several vendors over the years. On a scale of 1 to 10, how likely are you to recommend this to your friends or colleagues? If you say 9 or 10, that's a 0.4. If you say 0 to 5, it's a point against, and anywhere in between is basically neutral. Add that up and kind of average over 100, and that's where you get a score. And so, it becomes hard to even get a positive score for a lot of companies. World class is somewhere around 40, and to see us around 75, I think really underscores the fact that we've brought a simplified product to a market that needs it, which is we really focus on the small to mid-size IT group. Typically, our end users have 1 to 5 IT administrators within their organization, sometimes up to 10, but really our focus is on that 1 to 5 group, which is why we love the Spiceworks community so much, because that's made up of so many just perfect use case target customers of scale computing. And I think you'll see here that the product that we've brought to market addresses the needs that you have, and it's not a enterprise product where we've defeatured and repriced and tried to force it down market. We've literally just created a product specific to your use case. Now, before I do the demo, there are really 3 things that I want to focus on and want to make sure that you see in the demonstration. One, it's the high availability of a virtualized server and SAN. So it's that do-it-yourself architecture without the complexity. It's the scalability of a clustered infrastructure. What happens when you run out of space, and what happens when you need to add more VMs? How does that process work? And then finally, the simplicity of a single server. And I think the best way to demonstrate simplicity is not about talking about it, it's actually going through the demonstration. So I'm going to try to switch here to our demo. And David, I'll ask you to confirm that you're able to see it here in a second.
Yeah, absolutely.
Are you able to see that okay?
There we go. Yep, just came up.
Okay, great. So a little delayed, so I'll try to hang around as we're talking about this. But essentially what you're looking at here is I've got my Chrome browser. I've pointed it to one of the nodes in the cluster. Ahead of actually doing the demonstration here today, I had taken 3 HC3 nodes. These happen to be HC2000, which is just a model. I have racked them. I've cabled them up. I've both power and networking. These each have redundant power, redundant networking. I have gone through and assigned an IP address to each of the nodes in the cluster, and then I hit initialize. Most customers that I talk to are able to get up and running within an hour and start creating VMs. And so essentially what you're looking at here is once I've initialized the cluster, walk back over to my desk, and I point my browser to one of the IP addresses associated with that, and I'm presenting with my UI in its entirety. This is your entire infrastructure. So across the top, you'll see my 3 nodes, 1, 2, 3, and you'll see on here I have VMs that are running on each of these nodes, and you'll see, I kind of have them grouped by different things. My production VMs, I've got some that I'm using compression for replication, a group of Exchange VMs. Really what you need to know here is that there is a grouping of VMs that's pretty simple to set up. But I want to walk through, I think that to really underscore the simplicity of the product, I just want to walk through how easy it is to create a VM. So I click the Add button, which is how you create. I'll give it a name. I'll give it a description, and then a tag. So if you don't press a tag, we actually just kind of put it in its own group. If you do select a tag, we have, here are the ones that I've already created in here. I'll add this to my production group. You can add multiple tags, which allow you to search a little easier. The first one you put in is actually what that grouping comes from. And then I'm going to select my operating system. This is just to tell it, is this a Linux variant or is this Windows? If it's Windows or a Linux variant, we're able to make use of performance drivers that we ship along with the product. Then I'm just carving up the resources, right? There aren't multiple steps that I'm having to go through of the storage layer on up to the VM itself. I'm literally just saying, okay, I'm presented with a pool of all the resources in my cluster. How much does this VM need? And I can go through and select, what that looks like. So I'll give this 8 gig. I can add drives. And in my Windows world, this is my C drive. Super simple. And then the final step is, what am I going to run here? And so I'll just I'll pick this Windows ISO that I've already preloaded onto the system and hit create. And here is Craig 1. You'll see it's creating here. And after it's created, I can start that up. You notice that nowhere in there did I have to specify I want this to be highly available. Everything that you create on HC3 is automatically made highly available. And really what that means is you'll see this VM pop up on one of the nodes here. Once that VM is up and running on HC3, all the data is striped and mirrored across all the nodes in the cluster. Here you'll see it came up on node 2. Once that's on here, that means that if this node were to fail, that VM is going to automatically restart in the available space on either node 1 or node 3 in the cluster. So I'll pull up my console here, and you'll see, just like whether it's a virtual machine or a physical Windows instance, I'm presented with my standard Windows. Let's set up the system prompts and kind of go through. And as that's doing that, I'll go and install. While that's doing that, things like live migration, because we're sharing the storage across all the nodes in the cluster, I can do things like live migrate from, say, node 2 to node 1 just by clicking on that. And you'll see that it's moving that here in the background. And very simple to use. Once the end users are connected into that, whether it's you're connecting to it through remote RDP or whether your end users are making use of an application running on that, that live migration, it's in VMware speak, that's your vMotion. It's going to stay live. It's going to stay online. Your end users aren't going to notice any blip or anything like that associated with that move. There's no downtime associated with it. It just kind of moves over. It copies the memory footprint from node 2 to node 1, and you're off and running. Here I'm still kind of continuing on with my license agreement, custom install. I can load my drivers here, which we include along with the system, and you're off and running. So that's, I think the simplicity we talked about in the creating a VM. We talked about high availability and that live migration feature set, which again comes along with the system just straight out of the box. The last thing is the scalability. What happens if I start reaching the utilization points within the system that cause errors? What happens if I don't have enough free space to fail over a VM? What do I do? Well, it's actually pretty simple. You start with a 3-node cluster at a minimum. Beyond that, you can just scale out. It's not just scaling out the storage, it's kind of a scale-out infrastructure. So when you need more space, let's say you've reached 70% of the space utilization on the cluster. First of all, you're going to get an alert. It's going to be emailed to you. It's going to be displayed here in the UI. You're going to be notified that, let's say, you've hit that 70% threshold. In that notification, it's going to give you exactly what to do. First thing you may do is actually call our Scale Care support team, which is based in Indianapolis, Indiana. They may log into the cluster, verify, yep, you actually have hit 70%. At that point, you can just order another node. And it doesn't necessarily have to be the same node type that you created your first 3 nodes with. If, for some reason, let's say you purchased another company and have to accommodate for that added infrastructure of taking on that company, if you wanted to buy a higher-end node that happens to have more RAM, more CPU, more disk space associated with that, you could add that onto this cluster and still manage it from the same user interface of your entire infrastructure. And what happens when you add that on is those disks are automatically made available to the VMs that are running on here. So a lot of times you'll see an increase in performance associated with these VMs, and then you'll automatically have that extra space to write to start kind of continuing on with your system, and all of the alerts that you saw will be alleviated. They'll be cleared in the system automatically, and those VMs stay up and running. There's no downtime associated with scaling out the system. So those are kind of the 3 core tenets, right? You've got the simplicity, you've got the high availability baked in, and you have that kind of understanding that the system isn't just what you bought today. It can scale out to meet the needs of your workloads as your workloads change over time. So David, with
very
that,
impressive.
Yeah, thank you. Was there, actually, before I close that out, was there anything else you wanted to see in the user interface or anything you had questions on?
Yeah, I mean, as you went through the process of installation and some basic administration there of a VM, I mean, coming from a VMware background, having implemented it many years ago, one of the things that popped into my head, was the differences. Because I just have a bad habit of that, comparing things. But anyway, one of the differences I thought was interesting is there was no centralized management server that you had to deploy. So you didn't have to create a new, say, vCenter VM and put it on a single host to manage all three of your hosts there, from one point. That centralized management was just integrated basically into all of the hosts. Am I correct? So that if one host goes down, it wasn't like that host had the centralized management. Really, all the hosts have the capability to provide that.
Yeah, that's exactly right. We basically make use of the same distributed system that we're using to write all the data for the VMs, and we have our entire management interface, on that same distributed storage. And so because of that, it's available as well. Whether if a VM goes or if a node goes down, you can access the entire UI, your entire infrastructure, including that down node from another node in the cluster.
Yeah, and then for high availability for a VM, you didn't have to create a high availability, cluster. You didn't have to create some sort of centralized storage repository for the VM, and then worry about the 3-2-1 pyramid of doom. You didn't have to do any of that. High availability was just on by default. It was just part of the VM's configuration. I find that really impressive. The other thing is the complete visibility across all the hosts. So even if you have, say, like vCenter, you can create a cluster and you can see CPU and memory, sort of shared resources perhaps, but getting complete visibility across the storage is much more difficult. If you have a storage array of some kind, you have to go to the storage array and see the performance and the capacity from the perspective of the storage array. So here you guys have integrated that across. It's visible across all the management nodes in the interface, no matter what main resources you're talking about there. And then if you compare that to a VSA, the VSA approach, to boot up your storage, you first have to boot up the VSA, and the VSA is a VM. So first you have to have your hypervisor. So you get into kind of this chicken and the egg, approach. Before you can boot up any VMs, you first have to have these other VMs running. So it can create a lot of complexity, and I feel like downtime and troubleshooting issues. Whereas you all have integrated the storage layer really just into the hypervisor. It's hypervisor integrated storage. Am I getting all those things correctly?
Yeah, and that is the distinction. In a VSA model, it does accomplish a lot of the same things, and we talked about the cons of the complexity. I didn't necessarily point it out when we were going through the VSA model, but if you just think about it conceptually, for a write to occur, or even a read, but let's focus on a write here. For a write to occur, every write that you write actually has to go through the hypervisor twice to get down to disk, because it has to go down through the hypervisor to be told to that VM that's running on there, the controller VM, that it needs to be written, and then that controller VM goes back down through the hypervisor to tell the disk where to place it, basically tell the system where to place it on disk. So there are actually inherent performance boosts that you actually get out of not doing that VSA model with the hypervisor and hyperconverged solutions that actually integrate within the hypervisor itself. You have this benefit of shared storage. You've got their shared memory between the VMs that are running on there and the system itself, because everything is running literally within the kernel. So it's extremely fast, very responsive. It's one of those when you're looking at that diagram, it's probably easier to conceptualize, but it's one of those things that it's just an added bonus. One of our CTO likes to reference this RFC from years ago that basically boils down to you basically are not able to make a system better by adding things to it. The best way to run a system, especially an infrastructure system, is to take out all the unneeded things that you don't need and just focus on the pieces that are required. And that's what AC3 does. We've kind of removed a lot of that complexity by removing that traditional storage protocol and integrated within the hypervisor. So it's a great point, David.
Very nice, very nice. I mean, I know in the traditional, DIY virtual infrastructure, I mean, when you go to purchase it, let's say you've got your servers, which you may or may not already have. You've got a virtualization hypervisor you have to license, a centralized management, application. If you have, say, more than 2 servers, you're going to want that. And then most likely a storage array. If you're buying a centralized management application, you want to take advantage of high availability, some sort of, SAN or NAS type solution. And then, of course, guest operating system and application type thing. How do you guys license the Scale HC3 solution?
Well, I mean, just to start, we try to be as transparent as possible about pricing. To get started with HC3 at our entry-level system, which is, all SATA drives, 32 gig of RAM per node. It's not the biggest system out there, but it's 25.5, and that includes the licensing, which we don't ever call out separately, even for renewals. That includes the hardware. That includes 1 year of our Scale Care support, which means that, if you have a problem, whether it's, hardware, it's going to be covered under that Scale Care warranty. If it's software and you need to call in or you need to chat with us online or get onto our portal, that's all included. And again, those are our own internal people sitting in Indianapolis, Indiana, ready and willing to take that call to help diagnose any issues. And then, of course, we built into the product things like the ability to remotely diagnose things by a reverse SSH tunnel, so we can have access to the consoles if we're sitting directly next to you as the administrator.
And to me, that's also very impressive, especially for smaller-sized businesses where it might be a one-man shop, or maybe even if it's a 5-man or woman shop. You still, when you have a problem, if you were to call your hypervisor vendor or storage vendor or whatever, if you don't have finger pointing, let's say, in best case scenario, providing them remote access and getting them the information they need to diagnose the problem, in many cases takes a lot of time, actually. I mean, you wouldn't think it would take that long, but getting them somehow remote access to it, or getting out the debug reports and logs and sending them those off and sharing them with them and getting them everything they need to try to figure out actually what the problem is, takes a surprising amount of time. And in that time, your end users might be, suffering downtime or performance problems. So, I really like that remote access feature you all have, where you can click a button and someone can take a look at, exactly what you're seeing and figure out very quickly what the problem is. And I know you guys are able to do that because, well, not just because you came up with that remote access method, but because you all own the whole stack. You are creating and selling the whole stack, the compute, the storage, the hypervisor, everything. So you're able to support it all as one complete solution, which is very unique.
Yeah, I think you're right. I think it's a simplification of that allows us to offer, just hands down amazing support. In fact, if for all you Spiceworks users out there, check out our reviews online, and you'll see this common thread throughout most of them. We've got about 25 out there now, but almost every one of them invariably calls out our support team for just how amazing they are. And I do think that, yeah, they are absolutely amazing. I would never discredit them in any way, shape, or form. But I will say a lot of it really just comes down to the simple architecture that we have, and the fact that because we own the entire infrastructure, there's no finger pointing. If there's an issue and you call us, we know it's on us to get it fixed. And so there's no, well, why don't you justify why it's our problem before we actually dive in and try to fix it.
Right, and I like that. So we've got a lot of good questions from the audience coming up out here. Let's go ahead and take some of those questions now. The first one is about P2V. How can I've got a physical server now. How do I move that physical server into the scale computing hyperconverged infrastructure? Craig?
Yep, great question. And in fact, there was another one right after that was kind of, how do I move from VMware to HC3? And I'll try to address both of those together because the process is essentially the same. We've got a product called HC3 Move that basically the way it works is you take your Windows VM, you install this agent on it, you create a new VM on HC3, and then essentially what HC3 Move does, it's a product that we've licensed from DoubleTake. Actually, Vision Solutions DoubleTake was the former company name, and it's actually their DoubleTake Move product that we've licensed. Essentially what that does is it takes byte level differences, kind of moves the blocks from site A to site B, whether that's the physical or whether that's VMware or Hyper-V, moves it to site B, that being HC3, and then once that's in sync, it will remain in sync until you say, okay, it's time to cut over, after hours, whatever time is convenient. Once you hit cut over, the VM at the primary site, whether that's your physical server, whether that's VMware, will go down, and we will spin that VM up on HC3, and basically downtime associated with that entire process is really the downtime of that restart. So 5 minutes typically, but it does depend on the size of the VM and all sorts of stuff around that. But super simple process. We also have a lot of in-house expertise around that. So we do offer services that can help end users to get from their existing environment onto HC3. And again, there are other tools we use as well. Some open source, depending on the operating system you're trying to get onto HC3. But yeah, it really is a fairly straightforward process that we've done several times for a lot of our customers. And we even have things like everything from here's the licenses, go off and do it, to here are your licenses, but let me walk you through one with our quick start. We'll walk you through here's how this works, and then we'll hand over the keys to you to do the rest whenever it's convenient. Or we have services that can do the whole kit and caboodle, move everything for you just through a services engagement.
Okay, so if I'm moving from physical, or if I'm moving from, say, VMware or Hyper-V onto Scale HC3, the process is pretty much the same.
Yep, that's exactly right.
Okay, cool. Let's see, another question here is, what about how do you handle site redundancy and data replication? So I know you talked about, for local high availability of the storage, basically it's continuous replication between all the HC3 servers, which are also providing the storage. Data is continuously replicated between them so that if one of the servers failed, the virtual machines that were running, that were using that host for their storage, they're not going to go down. Is that true? Yeah, so it's a great question. So because the demonstration I just gave you was actually a product that HC3 has been around for years, since I think 2012 now, early 2012. But the new user interface that I just showed you is actually going to limited availability on Monday. Included in that release, where we've got this new user interface, is the ability to replicate data from your primary site to another site. The way that works is it essentially makes use of the snapshot and cloning functionality that we have just innate within HC3 and within HyperCore, which is the operating system that we run on HC3. The snapshots are thin provision. Is basically just kind of metadata snapshots, and takes a quick point in time. You can quickly clone from that, and they're immediately writable, immediately bootable. What the replication does is it essentially does a continuous replication, which basically is on a VM by VM basis. We are taking VM level snapshots, kind of depending on which VMs you've selected you want to have included in that. We take the snapshot on a predetermined, say 5, 6, 7 minute increment, kind of depending on the size of the VM and how long it takes to move the data from site A to site B. But then once that snapshot's created, we ship over the wire just the differences between the prior snapshot and the new snapshot. And that is sitting there on the disaster recovery site waiting to be spun up in the case of a disaster. So if site A goes down, you go to the previous snapshot that was replicated over, clone it, it's immediately bootable, you're off and running. So it's super simple. I'd be happy to give a separate demonstration for anybody that has questions on the replication piece. I didn't touch on it too much today because I didn't want to get too into the weeds, but it is a very powerful feature that's coming out on Monday, and we're very excited about that. Very cool. So replication from site to site will be built in. So no longer do you have to purchase a separate, replication tool. And really that would work with any operating system or any application, because it's just based on a VM basis, right, Craig?
Yeah, that is exactly right. And again, there's no licensing. We try not to nickel and dime. It's basically if you've got an HC3 at site A and site B, it's included as long as you're on this version. Which again, if you're under Scale Care, it's a rolling upgrade to get up to the latest, and you're off and going.
Okay. So what if someone had, say, a VMware in production, and they were looking for a DR solution. Would it be possible to use HC3?
Yeah, that's a great question. We a lot of times we'll see customers, as you talked about. I mean, the adoption of virtualization has really been picking up over the last 5 years, and a lot of the SMBs that we talk to have already started down the path of virtualization. They want to make sure they're able to use their existing infrastructure in some capacity, but they also want the simplification of what HC3 brings and hyperconvergence in general brings. And so one way to accomplish that, that same HC3 move tool that I described, there's a related product called HC3 Availability. It's licensed on a per node basis, and again, we've got an agreement with Vision Solutions on their Double Take product to offer this. Within the guest of those VMs, what you can do is you license the node on HC3, you license the host with VMware, and within the VM itself, there's a guest agent that you run that's able to handle that replication on a VM by VM basis. And it allows you to, at your primary site, run Hyper-V, VMware, physical environment, whatever the case may be. And on the other side of it, it can be HC3. And so people will say, okay, I know I want to move to hyperconvergence. What's my path to get there? And so they'll look at HC3. Can I somehow implement disaster recovery using this tool? You absolutely can. You would, essentially when people come to us, they say, I want to put this as my disaster recovery. They see the simple interface. They see how easy it is to use on a day-to-day basis. And they'll put that as the primary and then put their existing VMware infrastructure off at a DR site and then use this availability tool to have that failover between sites, even if they aren't, light hypervisors between the two. So that's one way. And it's also a path from, you start with HC3 at your primary and VMware, and then once that VMware site gets a little old, you can ditch that, put your existing HC3 infrastructure at your DR site and get a new HC3 cluster, and then make use of that replication functionality that we just talked about.
Right. Yeah, I know. I mean, most companies are leasing their hardware, these days. So usually, every 3 to 5 years, you've got the hardware refresh, that has to be done. And at that time, it'd be great to evaluate, what you were paying to lease your existing, servers and storage and VMware licenses, maintenance and support, with Scale Computing's HC3, and just see if it would be a good cost-saving solution for you. And speaking of that, what's the most common, or what are the likely scenarios where people adopt HC3? I guess I just mentioned one there, hardware infrastructure refresh. So they've got something coming up on lease. Another one we talked about, maybe DR. Mm-hmm. What other scenarios?
It's just a handful of things. Typically, we'll see customers come to us when their SAN and NAS is old, out of date, and they're ready to refresh that piece of the infrastructure. Because of the cost is so dramatic on the SAN or NAS, they look to replace everything with HC3, and a lot of times for the same cost, they can get an entire new infrastructure. So that's a big one. As you mentioned, the host servers, that's another big one. Once those start failing, you start getting concerned. How highly available is this system? As soon as one of them fails, you bought all of your host servers at the same time. How long before the next one? So you rush out to get a new solution in place for that. And then the last one that we see is with the hypervisor licensing. If you purchase 3 years or what have you, you're coming up to the end of that. How much does it cost to continue on with hypervisor? Or a lot of times VMware specifically has a nice little threshold. When you get from that third host to adding the fourth host, you automatically jump out of the entry-level pricing that they had into their kind of standard edition, and there's usually a substantial price tag associated with that. And so a lot of the customers buying too will balk and immediately go out and start looking for other options out there, and then that's when they come across HC3.
Okay. Yeah, I can see that. Any sort of hardware or software, refresh or maintenance, or new purchase like a DR or a remote site, all would be great scenarios where you would look at a hyper-converged solution like HC3. What about traditional hypervisor features? I know you talked about high availability, snapshots, cloning. Is there, and what other storage functionality? I guess what I'm asking or trying to ask is, the traditional features that we look for in a SAN or a NAS and a virtualization platform, are those there?
Yeah, I would say, well, some of them are actually hidden because it's not necessarily user-defined thing that's needed anymore. All the nerd knobs that you had back in the day of the traditional do-it-yourself virtualization, a lot of those can be assumptions that we make under the hood to make intelligent decisions with this. We have state machine technology, a lot of intelligence built in to make decisions based on how things are changing, what's going on, both at the hardware level all the way up to the operating system level. So some of that's just gone, and it's a good thing. It's your time's better spent doing other things than turning nerd knobs within the storage array or the hypervisor itself. So there's that. The other things that we do expose, as you said, snapshots, cloning, live migration, the high availability piece, kind of all that core functionality you would expect, and then some advanced networking things, VLAN support, that type of thing. It's not, you didn't see it in that initial VM creation dialog, but if you go back in to edit, there are a few other things that you can turn here and there to make sure that it's matching up to the environment that you're putting in and make sure the VMs are running the way you expect it to. Does that answer your question?
Okay. Yeah. So what I am hearing you say, I think, is for the vast majority of small and medium-sized businesses, we have everything you need, not what you don't need. And it's all that stuff that you don't need that traditionally creates so much complexity. For example, Microsoft Office. There's all these new revisions, but what do people use it for? They go in and they type some words and they do spell check and they print it out. 99% of the features, 99% of the people never use, kind of thing. And that's what makes it so bloated and big and complex. And, kind of like you mentioned earlier, your founder, he believes in getting rid of everything you don't need and leaving what is most critical and what makes the product, most successful and efficient and high performance. So really, really great information, Craig. Are there any further questions here that you want to talk about?
Yeah, I will say there are a number of them that are around, we talked about the site level redundancy, a few of them on backup. Do we work with Veeam? And I'm going to try to answer these as much as I can. I'll stay on after the call to try to answer these just in text, but then we'll follow up with everybody separately as well. Veeam doesn't actually support KVM, which is the hypervisor that we use under the hood, so we're not able to work with Veeam, which is one of the reasons we've come up with the VM level replication that we do offer within HC3 or within HyperCore. So we're able to kind of get around some of the need for that. There are other backup products that we work really well with. In fact, we just had a meeting with Unitrend last week around some joint marketing that we're planning with them, and we know that it's a tech solution that works really well, as well as a handful of other kind of backup vendors. Basically, any inside of the guest backup agents work really well with HC3. And that's a lot of times with the customers I talk to coming from a physical world, that's what they're used to, and they'll go ahead and just continue on with using that, which is a nice transition piece until we're able to come out with this VM level replication and VM level backup on that basis. So that's one of the questions. A couple others I may have to ask some follow-up questions on just to make sure that I'm understanding exactly what it is, and if it requires a separate call, happy to do that as well. David, I just want to thank you again for your time today. I think you did a great job on the presentation. Thanks for moderating all the questions that came in at the end. For those of you who are active Spiceworks users, I'm a green guy in the community. It's just Craig, Scale Computing. Feel free to send me a direct message there, and I'm happy to respond. Otherwise, Emily, we'll turn it back over to you.
Awesome. Great presentation. I do want to remind everybody that if your question wasn't asked live, Scale will be able to follow up with you. Also, if you had to step out or miss any part of today's presentation, you will be receiving an email in a few days with a link to view the webinar on demand. Thanks to David and Craig for the great presentation, and I hope everyone learned a bit more about hyperconvergence. Special thanks to Scale Computing for sponsoring today's event, and also special thanks to every one of you for tuning in today. We hope to see you back soon for another Spiceworks partner webinar, but until then, stay spicy.